Wonderful, wonderful. So till yesterday, what we learned was we we were at this point. We did a couple of interesting things. We did a little digression, and we talked about indexing, and we also talked about a big O notation briefly. All right. So yesterday, some of the questions were related to the big O notation. Okay, so big O notation generally reflects what is the order of complexity. Okay, and how does it reflect? It basically shows you that the input data, how much approximately time, or what is the relation of time taken by the program with respect to the input data. What is the relationship? It is a linear relationship, or it is square, or it is logarithmic, or is it exponential, right? So that's what big O notation do. And we also learned that when we sort something and we are doing the binary search, as in kind of bisecting the data into two parts and searching only in the part where we are expecting. So in those cases, the binary search kind of cases, the time taken is proportional to logarithm of the number of records. Okay, and we also discussed that the time taken will become double if the record become 1,000 times, right? If the, sorry, if the records if there were 5 seconds taken for 1,000 records, it will take 10 seconds for a million record to search. Okay, so that's what we discussed yesterday, and how dramatically the binary search solves the problem. So and when we talk about databases, big data, the searching and sorting is at the heart of everything. The searching and sorting is at the heart of everything. Like, for example, when you think of Hadoop, Hadoop is nothing but a big sorting a program which does sorting of data. Similarly, the reason why Spark became successful is because Spark was able to sort data faster than Hadoop. All right. So again, Spark is kind of at the heart of it is the distributed sorting machine, distributed software which does the sorting under the hood, which provides sorting. So so basically the sorting and searching is at the heart of almost every software, and we will learn it more as we go ahead. All right. So great. So a question from Mohammed: how do you decide which column to have an index? And in a database table, if you so the way it is generally done, we observe all the queries on the database. So a database has many tables. Each table has columns and rows, and we observe the database, and we see that if there is a particular column or particular combination of a column which is being used in where clause, meaning on the basis of that particular column, we are searching very often. So we generally index on the basis of that column or or multiple columns. All right. So if we are searching very frequently on a particular column, we generally index that. Okay. So that's the idea behind the indexes. Great. So moving ahead, yesterday we talked about these aspects, then we talked about big O notation. All right. Further question from Mohammed. This is a very important question. I think all of you should pay attention to each other's question. And the question is, okay, the question is, would you prefer an integer type column over a string type column? It all depends. It all depends on the data type. If I can save the data as integer, I will keep it as integer. But sometimes, let's say there is a particular thing that is being repeated again and again, we give it a name and put it in another table, and we basically refer it like an integer. That's called normalization. So in normalization, what we do is, if instead of referring something by the string, we generally give it a ID, put it in a separate table, and refer it like a number. Correct? So that's called generally a part. That's part of the normalization. And so sometimes whenever this table will be queried, you will join it with the other table and give out the results, right? And and if there are just too many joins in some of the cases because of so many tables and so on, so sometimes we do prefer to do denormalization. All right, we do prefer denormalization. All right, which means we do prefer keeping all the values as such as a string in the table instead of referring them as ID by putting them in another table. All right. So that's a quick answer, though the whole thing requires a bit of more detailing. So a question from Alok is columns which part of filter in the query. That's right. Thank you, Alok. And yes, thank you, Hiten. That's correct. All right. Sure, sure. So every database optimization has normalization at the heart of it. Okay. So whenever we think about, there is a CORDS rule for normalization, and you should take a look at that. And I'll also give you something to read about on normalization. Okay. So would you prefer, okay. All right, great. So let's move ahead. Mohammed, you are unmuted again, so please make sure that, okay. All right, now, so where we were talking about collections. In collections, we have, let me go back again from the beginning. Okay. A quick question from Hiten. Is it easier to sort string bytes rather than the number, which could be in binary form? It's actually the same thing. Okay, it's actually the same thing. The time complexity is based on number of items to be sorted, and therefore it's actually similar. Okay. A question from Alok is, when we need landing zeros should not truncate by integer columns, we convert that column from integer to string like this. When we need leading zeros should not truncate integer column. Okay. When we need leading zero, okay, should not truncate by integer column, we convert that column from integer to string like this. Okay. Okay. Yet to get the, okay. A question from Hitendra was that, is it easier to sort string bytes rather than number? It's actually easier to sort numbers than the string bytes, because under the hood, string bytes are nothing but bunch of numbers. Each character is a number, right? So when you have, like, when you're comparing two strings, So at which one is bigger or smaller. So we go from left to right, and we compare each character against the other character, right? While if it was not just a single number, it would be quick to compare, right? So if there are a bunch of numbers, 1, 2, 3, 4, 5, so it's quick to compare. But if they're strings, we compare character wise, and that takes a bit more time. All right. All right, wonderful, wonderful. So here, yesterday we talked about this Scala collections. Scala collections have one thing at the heart of it. This one is called traversable, and then we have sequence, okay, and then sequence has subclasses and so on. So this is the one. So we'll talk about a bit more about collections as we go ahead. All right, and we'll do bit more examples on this. Okay. So because collections in Scala are actually just too much, just like far more involving. So it would be better that all of you basically read through the chapter on Scala collections. I'll give you the chapter link. Okay. So, all right. Now, so we were discussing about the list yesterday, and after that we started with sets. Now, sets is something that's bag of data with no duplicates. Okay, bag of data with no duplicates. So sets is like a list, but you cannot keep duplicate elements in the sets. Okay, so sets are bag of data with no duplicates. The order in the sets is not guaranteed. Like in an array, when you keep things, they are at an index position. But in case of sets, you can never guarantee the order of the sets. Okay. All right. So let me just give you the link. So order is not guarantees in this. Also all right. These are the basic two important ideas about sets. So in many cases, what we want to do is let's say we have bunch of items in one box and in bunch of items in another box, and we want to see that what are the common items in both the boxes and what are the non-common items in both the boxes and things like that. Those are called union and intersection. So those kind of operations are provided by sets. And so let's take a look at the set. Okay, let's take a look at the set. So the set looks like this. And let me just skip it. A question from Sachin is that how double and circular linked list is implemented in Scala. You can actually create your list of objects, right? List of objects. And that object can have the link to next and previous. And that way you can actually implement your own double or circular linked list. Or you could just have a list the way we did uh, earlier in using Java and others. All right. The common things, I think I should give you this Scala collections, right? So this one is a very good document. You should take a look at this detailed document on collections. It's a detailed document, and it talks about all the whatever we are talking about. It talks a little bit more detailed into that. So these are the basic data types that are provided by provided by the collections of Scala. All right. So you should take a look at this. All right. I'm just giving you the link. Sorry. Now, coming back to the question about, okay, so So let's take a look at the how do we define sets. I'm going to switch back to my Scala uh, notebook. So I've just defined the set. So if I say set here, I can see it's a set. Now, if I say set 0, does it return any value? No. It basically gives me whether that particular element exists or not. Okay. So you can see it basically gives me the element that way. If I want to add something to the set, I can say plus, and so we can just add 29 and so on into the set. If I want to check whether a particular element exists or not, I can just check using this and so on. Okay. All right. So sets are basically collection of elements, and probably the for a in set, all right, print, all right. So you can iterate over the list of items using a for loop. Okay. You can see the the order the order is not guaranteed. Okay. A question from Alok is why we are not using colon when adding into the list. Yes, good question. I think it's a different what do you say, different annotation in this case, and that's why the difference. I think this is due to the difference between the hierarchy of classes. So here. There are sequences and sets. I think those which are sequences, you need to say colon plus, and those which are sets, you need to just say plus. Okay, I think that could be the only reason. And I also find it a little weird, but this is something that is that they have implemented. A question is, it basically is returning a new set when we are adding to it. Okay, so we could always do import Scala.collections.mutable. I'll just talk briefly about it, although we are going to cover it in more details. Is my voice audible to all of you? Okay. There must be something wrong with the Jupyter Notebook. Actually, this Apache Tori is something that's not really nice. Okay. All right. Wonderful. So we were talking about this. Adding 9 basically adds the 9 element into the set. You can take a look at this. Okay. So let me just run these two. Okay. So you can see the new set has, so new set was supposed to have 9, but since it was already there, it did not add. If I add 19, the 19 will get added. Okay. Great. Now going ahead and here, so we were talking about the set. So, all right, of course, we can iterate over the set and also, right? we could, I think, remove the element from the, say, this. All right. So we can remove the elements from the set using the same mechanism. We can iterate over the set using the for loop, and we can check if an element exists using the index way. We can use it using the index way. Okay. So basically, the way you can look at the data sets or data structures, there are first classification is they are mutable and immutable. Okay, most of the data set, basically most of the collections are by default immutable, meaning they cannot be modified. Therefore, we are assigning it to the new one. If we don't assign it to the new one, if we just say, if we just say set set plus 6, okay, it would not give you the correct results, right? So the set will always, the older set will always remain the same. So you can see that this is basically the set is essentially the immutable here, right? So in Scala, it provides you the I think, okay, we are going to talk about it after tuples. I'll talk about it after tuples. So we just talked about sets. In sets, we can add elements, remove elements, check if an element is there, or iterate over the elements of a set by using the for loop and other operations. Okay, now this is a very interesting concept called tuple. Okay, two questions before I jump to tuple. Question from Alok. In Scala, we are not using anywhere new operator to allocate memory. So memory allocation, delocation happens in the Scala. Yes, that's a good observation. So when we are saying set this is essentially we are saying new of set. Okay, we did not have to explicitly say new. Okay, we did not have to explicitly say new because this was equivalent of saying new. All right, here this is the point where we are creating new object of set. All right, so okay, now a question is from Hiten. When you add to a set, it creates a new one. That's right. Here it's creating the new one, and that's what we're going to talk about in quickly. Question from David, go back to slide 40, paste the loop code for accessing, okay, sorry, go back to the slide 40. If 9 is already in the set and you add another 9, there will be 2 9s in the set. No, there won't be 2 9s in the set. So let me just show you. So right now, let's say we are having set equals set plus 5, right? It already has say 5. Now, if I add one more 5 into it, the set does not have one more 5. Okay, so effectively your observation is right that there is no there are no duplicates in the sets. All right, good, good. uh Question from Grishma, can you please paste the code for the accessing this? I'll just write it for you. So a, and this was a standard phrase we used, right? Or standard slang we used. Okay, so this is how we could do. And I just want to try one more thing. If I say set and I say map and I say println, does it work? Awesome. Okay, so one more thing to notice about this is we could say things like for each. Right, so this we are going to talk about very soon. All right, now the next important collection is tuples. What does tuples do? Tuples are basically kind of uh, it's how should I describe? So tuple is essentially used for the cases where you need to pair things together, right? let's say you want to define something called a rectangle, right? Rectangle, right? So, so what you will do classically in Java, let's say you want to define something called, um, let's say rectangle, right? So rectangle is defined by x left, right? So we say x of top left, or we can just say top left and top left x and top left y and bottom right x and bottom right y. Correct? So this is how we would like to define. Now, whenever we want to say that, okay, resize a rectangle or something like this. So what will happen is we will end up creating a new class called rectangle. But sometimes we don't have that much time to do. Therefore, what we do is we use tuple. Tuples are quite interesting phenomena because they let you, instead of you defining the class, tuple internally define the class for you, and you can just happily use tuple. On the usability perspective, the way we use tuple might look like as if it's an array, but it's not an array. It's just multiple values together, right? The word tuple comes from comes from, again, it comes from the databases designs. Every row, so so the way we generally look at the database table is a set of, or you can say, yeah, the table is a set of rows, and each row is a tuple. Okay, so we are going to, yeah, we're going to talk about that, Prashant and Grishma, very soon. All right, good. So basically, when you are defining a tuple, you're basically defining the multiple columns, right? So when you want to define multiple values and you want to send it together, you could do either of the two things. One, you could create a list. Other, you could create a tuple. Tuple cannot be modified in the sense that once you define a tuple, you cannot change its values. You can redefine a tuple, yes, but you cannot change a particular tuple. So it's a tuple is a read-only value, read-only uh, ordered collection of things. Okay, read-only ordered collection of things. So there are two ways to define a tuple. There are two ways to define a tuple. First way of defining a tuple is we say where t equals just like this. Okay, so this t is our tuple, right? So so we cannot iterate over a tuple. We cannot iterate over the tuple as per my knowledge, but we can give it a shot. So so you can see we cannot iterate over the list of values of a tuple. Okay. Why? Because it is not iterable, and it is not something that has indexes. Okay, so tuple under the hood is not like a list. Under the hood, when we are saying this, when we are saying something like this, under the hood, this is an important observation, and it took me a while to see this. So under the hood, what is Scala doing is Scala creating a class for us. Okay, class for us which has three variables, 1, 2, and 3, right? So if you take a look at this, we have to, if you have to access the first element, we have to say _1, _2, _3. Okay, so if, let me just change these values, say 100, 200, and 300, right? And so we just defined, okay, print t dot _1, okay, t dot _2, t dot _3. And let me just put print ln. That'll look better. Okay, so you can see that this is how we access the values of tuple. All right, we cannot change these values. If we try to change it in any way, let's say I'm saying equals to 5, right? It says that we are trying to reassign to a bell. Okay, so these values are not changeable. Okay, and the way we access is not by the way of indexing, but by the way of accessing by their name. Their name, this one is named as _1, this one is named as _2, this one is named as _4. All right, the other way of defining a tuple, the same tuple, is by saying tuple of 3, and then we say 100, 200, and 300, right? So here, the do you notice the 3 here? The 3 is the number of elements, okay? And right, so if I just say 2 here instead of 3, it'll give an error saying that there are too many arguments. All right, there are just too many arguments. So basically, when we are defining a tuple, under the hood, Scala is creating a kind of object for us. All right, so tuple, or sometimes people refer it as tuple, right? They basically are for defining a bunch of elements together, which cannot be modified, which cannot be modified. All right, a question from Alok: is it tuple adding or normal element adding? In case of you are defining this, you can take a look at a good question. So here, when we are defining something like this, we are adding tuple to the set, okay? And it's basically taking all these elements and putting them as the member of this set, okay? So we are actually adding a tuple. Okay, a question from Sachin is, it means list and set are mutable. We are going to talk about this very soon, Sachin. So tuple2 is built-in class or our custom class. Tuple2 is a built-in class, tuple2, tuple3, and so on. And I'm not sure how many. I think you can define as many as you want. Okay. So, okay. And question from Grishma is that in real case scenarios, where is it used? Good question. So whenever we are dealing with say columns of a table, or whenever we want to pass our element and we don't want anybody to be modifying it, we send the tuple. Okay, and yeah, so when we are accessing the elements of tuple, we basically say _1, _2, _3. All right, if you want to iterate over the elements of this tuple, then you should not be using the tuple. If you are okay with not iterating with the elements, then you should use tuple. Tuple are very efficient classes, and they are a substitute for you creating your own class and then creating the instance of that one. So tuple are quite useful when you instantaneously want to bundle up multiple values together. Okay. Yeah, so it doesn't start from _0. That's a good observation. So it starts with _1, _2, _3. All right. A question from Bintao is, in Python, there are some special symbols to represent list, tuple, and dictionary. However, there is no such in Scala. That's correct. That's correct. There are some to represent in Scala, such as set, map, array, list, and tuple. What collections are not the same and have the different functions in Python and Scala? Okay, and all right. We will actually go ahead and talk about it. Don't worry. We'll do the comparison a bit later. Okay, so we do the comparison a bit later. We just get acquainted with basics of data structures and collections, and then Then rest of it we will do it probably later. Okay. Question from Hitendra is explain the difference between the set and the tuple, right? So in the set, basically we can remove element, we can add elements, okay? But the same thing we cannot do in the tuple or tuple. In tuple, the whatever we are passing, it can whatever we create once remains as is. Okay, we can't even add an element to it. Let's say we want to add one more element to some tuple, we can't really do that. Okay, we can't really do that. So there are tuple is quite restrictive in that sense that but it is read only, and it basically behaves as if you have created your own object which you want to access. Okay, yes, so tuples or tuples are great for immutable object. All right. And right, so it can be deconstructed into name bounds to each value in the column and so on. Okay, so now the next important part is maps. Maps are collection of key value pairs. It allows indexing values by a specific key for fast access. Okay, so the parallel to the Java's map or Python's dictionary, we have maps in Scala. All right. A question from Hitendra is when you add to set, you are creating a new one. You are not really adding to the set. That's right. But we are able to combine and add the attribute. That's even not possible with tuple. Let's say you want to add one more element to the given one and so on. All right. So a question from Grishma is so it takes more memory. It doesn't take much memory, so it is a quite efficient way of representing multiple values together. The list or the set would take a bit of more memory than the tuple. Okay. Moving ahead, so we have Scala's collections of key value pairs. Scala's collection called maps. Maps are nothing but a collection of key value pairs. They allow you to put you to access the way arrays or lists allows you to access things based on the index like 0, 1, 2, 3, right? Maps allow you to access things based on a name, based on a string. All right, based on the string or name, we call them keys. Let's try to see the, okay. A question from Alok is not enough arguments, right? So, uh, okay, yeah. So what does this error, so what are you trying to do here in this case? So the kind of error which he's facing, let me just explain it again. Okay. So whenever we are, so I did this right earlier. We were trying to define this, correct? This is the error that we got. That we were saying that our element will have two arguments, and we passed 3. Then we got this error, too many arguments for the method to apply. Okay, why? Because internally tuple2 is creating a, a object which has a constructor which can only take 2 elements. While here we are passing 3 elements. Therefore, it's saying too many arguments for method to apply. Okay, internally, if you think about it, it's basically creating a kind of a class for you. I wanted to avoid the class discussion right now, but those who are aware of class and objects and constructors, they can think of it that Scala is typing code for you. It's creating a tuple2 class, which has a which takes 2 arguments only, and but we are passing 3, therefore it is throwing that error. All right. So since you are from the Java background, you will be able to relate. Okay. So good. All right. Now let's see how to talk with maps. Okay. Great. Great. So here what you see is it's the way we define a map is by the way of either you could pass empty, you could create an empty map, or you could define the key and the value in this form. Okay, you see these special operators. These are special operators so that you can visually express that we are defining our map. Okay, so this is the default value here. So maps in a dictionary is the same thing, Prashant. In case of Python, we call it dictionary. And in case of here, we call it maps. Question from Binta is, we usually construct in Python data frame to manipulate with SQL and some function. And in Pandas and Scala, we use list to do the same thing. So yeah, good question. So when we are going to talk about the manipulating data, so we're going to talk about Spark SQL. Spark SQL provides you the data frame with which you can manipulate data. Okay, similar to pandas. All right. Here, if you want to just do it in core Scala, we'll have to create our own list, and list containing the row objects or tuples which we can manipulate. All right. So here you see that colors equals map. This is the key, this is the value, and here we're defining the colors. So saying colors, you can see it is this way. All right. We can access a particular value. We can access a particular value of a color. Okay. Well, what is the value of color? So just like we use the list 0, list 1, list 2, similarly, we are able to access the map by the way of a string, by the way of a string. Okay. Then further, if you want to add key value pairs, we can do this kind of a syntax. We say colors plus equals this. Okay, colors plus equals this, and probably this should also work. Okay, it doesn't work. Does this work? No. Probably this should work. Okay. So you can see that we have added green to it. Okay, so we could further do. All right. Okay, say purple and put some value for it. Okay, and so you can see we're able to add in these ways. One was by the way of constructor. We added some default values. That was the first way of adding values to the this map. Second was in second one was in the second one was by the way of just saying color plus equals, then specifying this value. Okay, we put the bracket around it. Okay, so right. And I'm not sure if it is a bracket is referring to a tuple. I think it's just a bracket, just normal operations bracket. Okay. The second one we did was we basically added in this way. We said color plus equals to this and so on, right? So this is the important part. We need to put this kind of a syntax. Okay. This might look a bit cryptic, but once you get used to it, it'll be easy for you. Okay, so we can subtract, we can remove a particular key from it. Okay, we can remove a particular key, and that key has been removed. All right, so we basically can remove. A question from Alok is, for tuple we need, I think, will not work for tuple. Okay, okay, but we can define a tuple and then test whether it works or not. All right. Also, we can iterate over the dictionary. So what is a dictionary? Dictionary is something where we can keep the name value pairs. This is the most frequently used data structure, or this is the most frequently used collection in which we will basically, most of the work can be done in the dictionary. Like word count, you can do it in the dictionary. Let's say there is a list of words we are loading from somewhere, and we want to iterate over the words and count their occurrences, right? So in those cases, we can simply just maintain a map. So we could say the initial of map, right? We could just define a map like this, right? And okay, let me just say where words, right? This is how I would say. And okay, so, and let me just see, just give me a second. All right. So if I say colors purple, okay, or say colors red, what does it do? It returns that value. Okay. Okay. So we can actually just use the map to implement various kinds of solve various kinds of problems like word count or any other things. 90% of the problems can be solved using the map. Map is a quick way of doing many things, but since map is in the memory, therefore it generally, if you are loading big data into the memory, into the map, then it overflows it, and therefore we need to be careful about the map. All right, some questions. Question from Binta is, as for this particular symbol in Scala, in what situation it is same as colon and equal and in Python? All right. So I think it's very different from Python, and here the symbolism is a little bit more. Okay, so here like we have colon plus, we have arrow keys, and we have the for loop iteration is arrow and dash. I mean greater than sign and less than sign and dash, and so on. So there are multiple notations in Scala for various things. All right. While in case of Python, the total number of data structures is probably two. One is list and other is dictionary. Okay, rest of it is managed internally. But here there are many data structures. Why? Because we are able to optimize things to a very large extent. Okay. So a question from Alok. I have defined tuple this variable, okay, and we got the results. Okay. All right. So I think probably that is a dictionary that is defined. Now we can loop over these colors, right? So I could say for and say a. We could use any other element if you are sick of seeing a again and again. All right, and we could say println and e, right? So every time it basically converts it into a tuple, right? This is basically the tuple. Now, instead of this kind of a loop, we could further make it something like key, comma, value, right? And we could just print key, okay? Or we could just print value. All right. So using this kind of a syntax, it becomes really easy to go over the list to go over a map, as well as if you want to find out the value of something, we can simply use this. Okay. So this was a quick introduction to map. Okay, and you could take a look at the this particular documentation as I gave you earlier to know more about it. So I would like to describe what is mutable, what is not mutable, and then discuss a bit of understand why it is that way. Okay, there are a couple of questions. So map is a mutable object. That's what I'm going to discuss now. All right. Right. That's right, Alok. The idea of having these kind of shortcuts is to be able to define the various collections really quickly. Like we were able to define tuple quickly, and we were able to define a list quickly, as well as you were able to define the map quickly. Okay, so all right. So it is basically really fast. Okay, now in Scala, there was a very interesting design discussion, and it's a very strange design from many beginners' perspective, right? So everything was having two kind of ways of doing. One was mutable, other was immutable, right? There was val and where, correct? When we are declaring a variable, every variable could be declared as mutable and as well as the immutable. So we we have two ways of defining a variable, either var, okay, or val, correct? So you might wonder that why there was a need, because this kind of a need wasn't there in any other programming language, right? Here, since the language was designed for high scalability, the Scala means scalable programming language. It was designed for high scalability. Therefore, when we scale something up, the parallelization comes automatically. What is parallelization? Doing things parallelly, whether on the same machine or a different machine. Therefore, since when the things are being done parallelly, the chance of overwriting corrupting variables is very high. Therefore, as part of the core design principle, the the two kinds of definitions were always there. One was where, other was val. On the same principle further, the collections of Scala were designed. There are basically two sets of collections. One is mutable, same object, exactly everything is same, just that they are changeable, and others are immutable. By default, everything we did was immutable. Whatever list we got and whatever map we got was immutable, right? What they were basically immutable. So essentially, for all of these data structures that you see around here, right? There are two kinds of implementations. For all of these, there are two kinds of implementation. This is immutable. These are immutable implementation, has set, tree set, has map, and so on. A parallel one, if you go down, are mutable. These are something that could be changed. Okay, so almost every object has two avatars, two versions of it. One is mutable and other is immutable. The default ones, that are imported into your default namespace, which are available to you as part of Scala, those are immutable objects, right? So you could take a look at these objects. So let me see if I could demonstrate to you. There are quite a few objects. There are quite a few objects that there are quite a few methods that you could see here, and there are quite a few symbols. You should go into more details. This class is supposed to be a basic overview of Scala, right? So when we are defining something and we want explicitly the mutable versions as well as immutable, so what we can generally do is import Scala collections dot mutable, right? So this way, is it, did I make a spelling mistake? Yeah. So this is something that you could always import. Uh, and then once you have imported this, then you can say my map is mutable dot map, and we can say this is my key and this is my value. Okay. So all right. So here, this one is a mutable map. Okay. What does it mean? Does it mean that we can add more values to it? Okay. So, all right. What happens if I don't do this? Okay. So, no, this is a syntax for not that, but we will have to say remove say x1. Okay. So, all right. All right. I could give you a better example. Let's say in my maps. Okay, so is there a way to call the remove element? Okay, so if I say, all right, it doesn't have the, okay, so you can see that we are able to remove an element, a key called X from it. Let's say we are using the default one. Let's say M. This is mutable, and we are defining. Let's say again the same thing we are defining here. All right, and let's take a look at, are we able to remove or not? All right, so it says that the remove is not a variable. Okay, so what's the difference? What's the difference here? Let me just clean it up a bit. Okay, so this is okay. All right, now let me explain what I just did, the example that I created. So I did two things here. One was using the mutable map. You can see mutable map. And I said that this map is going to have one key value pair, correct? The key is X and one is the value. So we can take a look at it by say running this example and then take a look. So you can see this one has this X. And the moment we say mm.remove, it throws it basically is able to remove it. Okay, it's able to remove the element. We can just check the value, it is removed, right? So this is mutable. We are able to change it. We are able to change the map. We are able to change the map. Now, the now we are basically taking another example where we have the map like this, and we've just defined x as a key and value as 11. And when we call this, it says that there is no remove member. Why? Because this M is of immutable map. By default, every data structure class that you get, every collection that you get, not data structure, every collection that you get by default in Scala, that is immutable, meaning you cannot change it. You can add to it and assign it to something else. You can remove it and assign it to something else, but the original one will remain the same. So we can actually do this kind of thing. So we could say M plus plus plus, let's say Y and 10. So we are able to do that, right? We are able to do that, but we cannot just call remove on that. So therefore, and this is the structure in entire Scala. There are, for map, there are two classes. One is map, other is one is for every class there are two versions. One is immutable, other is mutable, and by default we use the immutable one. Okay, so this is a kind of a design decision that Scala has taken, and it has basically, though it looks a little clumsy that why are there so many classes, but it is with the same design in the mind that it should be scalable design. We should be able to use our collections which are safe to be used across the threads, across the multiple processes, and so on. So this should be, it should be safe enough to be used by parallel threads and things like that. Was I able to convey the meaning of immutable and mutable? So we defined two maps. One was which was mutable.map. And where did this mutable come from? We imported this. We imported this. Okay, this is a package. All right. Okay. A question is, what's the difference between x and y here? Where x and val y? For y, we cannot reassign. You can see that. That's the difference between where and val. A question from Bintao is, could I convert a mutable map into an immutable one? Okay, it's a very interesting question. So I think you should be able to do that. Okay, let's just try to do. Can we do that? Actually, this is a very interesting question. Let's say I'm defining the casted mutable, and I'm saying mutable dot map, and here I'm saying m1, right? So here I'm saying m. So it says that value m is not a member of object class. Okay, or I can do that. There is something called as. No, it doesn't allow me. I'll have to take a look at it. So I keep this as a question that I would like to answer. Okay, all right. Okay, so yeah, that's a separate question I'll keep. A question from Alok is, so can we say which one defined by val is immutable? So which one defined by, so val is not changeable. We can't change any the value of val. Um, Actually, I did not get your question. So x was this is changeable, right? That means we can say x equals to 5, right? Happily, and this is immutable, right? And that's why this will throw an error. Okay, this is works perfectly fine. Okay, and this is an error. Okay. All right, great. So basically, this is the big difference between the other languages and Scala. There are separate two packages. One is called Mutable, having all the classes which are immutable, the copy of all of those. Just a tiny little differences. Okay. So by default, Scala uses immutable map. For mutable, we need to import this one. Okay, how to add, does add work? Okay, so how to add into map? Is that your question? Right. So I think there should be the function add. Let's just try it out. I think there is so okay, let's see if add works this way. Add is not there in this, so I think the plus is the only way to do it. Okay. Though I'm a little, confused about the performance here, because here, if you take a look at this one, this is essentially creating a new map, and therefore there are chances that, let's say, was there, right? Let me see this experiment. So let's say was there. Has what all? X as 4, correct? Now let's say I define another variable, copy, and we define this as right? And let's say we do plus equals, right? We are adding a variable and we are adding this new elements to it. Okay, now let's take a look at the copy. Copy would be pointing to the new one. Oh, interesting. So it actually modified it in place. Okay, this actually modified it in place. All right, so okay, so this is not equal to, so this, and let's say this is not equals. All right, I'll show you this. Is fine, but copy should be pointing to the old one. Yes. Okay. So the point I was trying to express is that this expression and this expression is not same. Okay. This expression and this expression is not same. You see that? This one is in place modification. This one is in place modification, while this one is not in place. Here we are creating, when we are adding something, we're creating a new object and assigning to this one, and this is where it is. All right. So how did I do that? Because what I did was I kept a copy of okay, and tried this as well as this. So this one still point to the old one, while points to the new one. That's why the and underscore copy are different. All right. So, all right, this is where things look little strange with the Scala. That this method that you see here. Okay, let me repeat again. So the way we add things into the way we add things into map is by the way of doing plus equals. Okay. In case of mutable and immutable, it acts differently. It acts differently. In case of immutable, if the collection is changeable, then this basically replaces the uh, data in place, while in case of immutable, it replaces in different way. Let me just show you this part here. Let's say we are defining, let me just describe you. This is my immutable map. Okay, and I'm defining it like this. Okay, and right, this is x is having 4 value, right? So immutable map is having this. Okay, just check if it is really immutable. Okay, by the way of this, it says yes, you cannot remove. So that means this object that you are having here is immutable. Okay, now let's keep a copy of this one somewhere, right? So I'll say im copy equals im. Correct. Now im and im copy both are having the same value, right? Im and im copy. Good. Now what we do is we take so we basically kept a copy of it so that right, we can ensure that nobody is changing it. So this im copy is essentially pointing to the same one. Okay. Now we modified this im, right? We modified this im by the way of adding y to it. Okay, we are adding y to it. Okay, it says, okay, let me just try. Okay, so you can see that the im has been changed here. So it sounds like that we have changed im, but not really. Okay, the original one should remain as such, right? You can see that the original one should remain as such. Did I make sense?
Sandeep,
Okay, yeah.
original one is IM, not IM underscore copy.
IM underscore copy is the original one. That's right. Oh, sorry. Before making the changes, we kept a copy of it.
Yeah, we kept the copy, but we are not allowed to change it. How we can allow to? IM is the original one.
Yeah, this is IM original one.
Yeah.
Okay, and this is IM copy. We just made a copy of it. Okay,
Okay.
and we just kept a copy. Now this is interesting, very interesting phenomena. This one that you see here is okay. Uh, let me put it down really clearly. Okay, if IM is mutable, then these two are not same. Okay, these two things that we are doing, IM plus, okay, these two are not same. This one replaces in place, and creates this one creates new IM. Okay, if IM is immutable, right, these two are same. Okay, these two do the same thing. They both create a new IM and change it. All right, so this is that's why it looks a bit confusing sometimes. So all right, so I hope this is now clear. If this object is mutable, then these two things that you see here are actually different. This one is doing the modification in place, and this one is creating a new object and assigning the new value to it. All right, and while if this was immutable, then these two are same. That's what basically what when I studied this whole structure, this what they have done is they created two parallel maps. One behaves both of them kind of behave similar way, and the immutable tries to give you the same experience as mutable, just that it would do things like this, that it'll create a new one instead of replacing in place. Okay, so it might look a bit confusing at times. All right. Okay. Now, this example was clear, right, to everybody, because it was mutable. So what we did was, before changing it, we made a copy of this one, and then we kept this copy as separate. Now, this copy, im underscore copy, was the copy of original. Then we modified this, and we checked this, and so on. All right. So I think this is okay.
Sachin, I have a question here. Copy in the sense, the
Uh,
copy
you
which we
you
have.
have a question for Sachin or for me?
Oh, sorry, Sandeep. Sorry.
Okay. Okay. No worries. Yeah, go ahead.
Sorry. I have a question for you. Here, if we make a copy of it, right? The
Hmm.
IM underscore copy, that
Yes.
variable, will it
Right.
be pointing towards the location where I am reside?
That's
Or
right.
okay, but when we make a change, right? If it is pointing towards the same location, so
Right.
it should all the
So
values.
this one actually is creating a new one.
Okay,
Okay. This one is basically this one and this one are equivalent. So IM equals IM plus this. These are both same.
okay.
Okay. This is same as this one. Okay, what's happening is, there was an original IM. We added this key value pair to it. It created a new dictionary and assigned it to this one. Okay, why?
So the
Because this
okay,
IM was immutable. Okay,
okay,
so this one and this one are two different one. This one was original one, which this one is pointing to. These both are having the same address, and this one is a new one.
I got.
Okay.
Okay, okay, thank you.
While in case of like in place, I showed you earlier, I was showing you earlier, right? This is an important part, because that's what kind of confuses everybody, that what's wrong with this, right? So what they have done is, the immutable one tries to pretend like mutable as much as it can. Okay, it tries to give you the same kind of operations. Okay, by the way of creating new objects. Okay, and here I showed you this part, right? We defined a mutable map, correct? This was the mutable map. So here we added X as one. Okay, then we tried to remove it, so it actually removed. Then we again added something to it, so it was working fine. That means it's a really something that is changeable. Okay, then we checked the value. Then we kept a copy of this aside, and then to this older value, we changed something in this. We added y to it. Once we added that there, we the older copy, the one before adding, right, also got updated. Okay, so that's what I was trying to demonstrate when in case of the mutable collection. Okay, mutable map. All right. So Grishma, you have more questions?
No, I think in this case, don't you think it will take more space if the map has more values? I mean, key value pairs.
So in the immutable case, we are
Yes,
actually cloning the entire map. So yes, in
correct.
the
Yeah.
below case, what's happening is, every time we are adding something to it, it's creating a new map, and
Mm.
hence it will take more space.
Okay.
Okay, so you are right.
Okay. Thank you.
Okay, therefore we need to be aware of this fact. So this one basically takes up clones the entire object, not this one. Okay, and this one, right? Okay, clones entire object. All right, when we are basically, there was an older object, we added to it. So instead of modifying the existing one, it created a new object pointed by this one. All right. There are so many questions. A question from, I'll just go from last one. Question from Vinta is, if I define a map with a var, that means it is mutable. Okay. Uh, no, actually that is a completely different discussion. So if we are, say, defining something like var equals to m, or let's say my map, okay, and we are saying map, let's say, just like empty one. Okay, now we won't be able to reassign the value. If we have val here, we won't be able to reassign the value to it. Okay, we won't be able to say this equals this plus plus say x and 1, right? It'll say it cannot reassign. So the definition of val is that we cannot assign new value to it. Okay.
So, Sandeep, so it means like val is the final variable or constant kind of things? Final.
Yes, kind of thing. Yes.
So we cannot reassign the value, but we can modify it.
We can, let's say, a good question, very good question. Let's see this. Okay, we are defining a mutable map. Okay, right? So this is my val, which is mutable map. Okay, can I add to it? Can I add to it? Let's see if we can
Yeah,
add
we
to
can
it.
add it, but we cannot
Right?
reassign.
See, uh,
Oh,
okay, let me just do that. Val plus equals this. Okay, and uh, am I making a mistake here? So it says that type mismatch. So it says string and this, and we are providing nothing. What's wrong with this? This should be okay, right?
yes.
Okay. So I think it doesn't allow you to do these even on the val. Okay. So okay.
If we do just map underscore m plus and this tuple, these things, will it work it?
Uh, yeah. One more thing. Let's say this, right? Can you just type what you're saying? Okay. And right. So let me just try doing this. I wanted to show you that that even though the variable looks like val, we should be able to modify things, right? So you can see this is basically something that we need to be aware of. So we have right now the map underscore m pointing to a map which is having x and 5. What if we call remove on it? Okay, we call remove on it. So we are able to modify the object actually. You see that? We are able to modify the object actually, though the variable is marked as val. The only problem is the only thing that val restricts us is that we should not be able to assign new values to it. Okay, we should not be able to assign new values to a val. Does it make sense to you, Bintao? So when we are marking this object as well, it does not stop us removing elements from this object, right? It it stops us from reassigning new values to map underscore m, but it does not stop us from manipulating the object. Okay. Was he able to explain, Bintao? It's a good important question. And now let me go to so Alok, is your question answered?
Yes, certainly. But if we take the map as a immutable without mutable dot map,
Then
so
yeah,
are we able to like modify this?
no, we are not.
Even though we cannot modify or we cannot the assign also.
Correct. So here, let's say I'm defining the default one. Okay, then it is kind of sealed. This object we can't modify. Object we can't modify. But if we are, let's say, defining anything, let's say I am defining a new map. Okay, this is let's say I'm defining some other map. Okay, so mutable dot map, and we are defining some other things, right? And all right, so this is my next map, and here while defining this, I pass the value of this one as mmm. Okay, now you see this. This is now sealed. We can't modify it, but we can definitely change this object, right? We can remove from it y, and therefore the value of map has changed. Okay, you can see map was this earlier, now it is this. Okay, why? Because the object that we passed here as the value, we have modified that one. Did it make sense? Though this object is sealed, this variable is sealed, but we cannot modify this object, as in the mmm, the object pointed to by mmm, or the variable itself we cannot reassign here. Here this one, but we if we passed an object, we can modify that one. So that's the only catch. So we need to be aware of the object that we are passing around. If we pass around a mutable object, the chance is that somebody would modify it. Okay, so we have to be aware of these facts. Okay, good question. Was I able to answer your question, Alok? All right, wonderful. So a question from Binta is, we can change a mutable map which is within an immutable one. That's correct. I think that's the best way to put it. Question from Rajan is, what if I do map m dot put this? Then this, it will throw error that you are not allowed to do this, right? Okay. So one is that put, it does not have a put method. Okay, we need to use plus equals. Okay, and right. So the plus equals it will anyway not allow, right? If I do plus equals and then say y and then put the arrow symbol, and yeah, it says it's not allowed. Okay, let me just see. Let me try to put a bracket around it. Okay, it says that there's an error. Okay. Okay, let's take a break. Just so far is the collections. There are two types of collections. One is mutable and other is basically two avatars of the same collection, the mutable and immutable. By default, Scala uses the immutable one, but you can explicitly import the mutable collections. All right, like for example, we can simply import the mutable package and then use the mutable whenever we want. Now, the next part is really important. Now, something called higher order function. This is something unique about, say, Python and Scala and any other procedural language. So, or functional language, we call that. So, so in Scala, there are these higher order functions which can take another function as argument. These describe how the work to be done in a collection. These describe how the work is to be done in a collection. Okay. Say for example, there's a higher order function called map. This is not same as the map collection that we just studied. This map is a function. This map is a function. Okay. So what it does is it takes an argument from you and applies that function again and again on every element of the collection. Okay, so this map is not a collection, it's a higher order function. It can take a function argument and applies it to all the values, right? Say for example, we have this list having 3, 7, 13, and 16, and we want to increase all of these by one. One way is that we could do the for loop. One way is that we could do the for loop. The other way is by the way of using map. You only describe your operation, like how to increase one element, what to do on each element, and then this part is your function. This function is being called how many times? One for every element. So 1, 2, 3, 4. 4 times it's being called. All right. So let's take a look. Let's take a look here. Imagine that we have a list. Okay. Imagine, let's say we have a list. Okay, and we are defining a list having, say, elements 1, 2, 3, 4. Okay. Now we can call a method called map on this list. And here we can pass our argument, right? Let's define a function called increment by 1. Okay, here we're defining a function called increment by 1, and it takes an argument as integer and returns an integer, and the body of this one is returning x into x, let's say, or let's say it's returning just increased value by 1. Okay, it's basically increasing. uh, so you can see this function is extremely simple. Okay, you whatever value you give, it just returns one increased value. This is clear so far? So we have a function which knows how to increase the value of an integer, right? Right. Now, if you want to call this function on every element of this list, either we could do the for loop over this list, or we could simply say list dot map and increment by 1. Okay. So here it has returned another list containing the values increased by 1. Okay. All right. Let's say we want to define another function. We call it, say, square. Okay. What it does is it just squares every element. It returns the square of the value. Let's just check if the definition was correct. And so square of 5 is 25. So it's working perfectly fine. Now we can call this square method using map on every element of this list. Okay, the value on this list right now is how much? It contains 1, 2, 3, 4, but when you call the square method on the list, it contains 1496. Okay, the output of this is 1496. Okay, does it make sense to you? So essentially, this is what is happening. Whatever function you are giving it to this map function, it's taking it and executing it against every element of the list. The same, basically, whether it's set, whether it's so this map function is available on everything that is iterable. Anything that is iterable, this function is available on all of those. Okay. All right. Now, Hitin's question is, these higher order function always work on collections. Why? Because this function, the map function, is a usual function. This map is just a usual function, which just happens to take an argument as a function, and it does the work internally, right? So this list, the list implements a method called map, and hence it is like this. All right. So basically, the map function is being called on the list, and this is what's happening. All right, is it clear to you? No? All right, is this the higher order function clear to you? If it's not clear, I can explain once more, else I can just move ahead. Now, this definition of things is little more verbose, right? When we are defining something like this, and then we are calling it on the map, right? We're calling it on the map, on the list. We're calling via the list, right? It's just two verbose. Every time we have to do something, we have to define a function, then we call on it. We can better use a for loop. So Scala came up with shorthands. The shorthand as in we can define the anonymous function whenever we want, right? So we could just define our anonymous function here itself. We could say um, x, okay, and x plus one. All right. So here you can see that what we have done is we have written an equivalent code of this one. We are saying that this function, although we can also shorthand it, we can also make it a little more shorter like this, correct? This is the one we studied earlier. So this function, we are defining a function called increment by one, right? Which returns value increased by one. We can further make it shorter like this. So we don't need to define this function anymore. We can just define this function inline, or we call it lambda function or anonymous function. All right. A question from Sachin is, so higher order function is applicable to every collection? That's right. Okay. So, all right. So you can see that this is basically these two things are equivalent. Here it takes like two statements to do. Here it's one statement, right? Now, this can be further shorthanded to this one. Okay, we could just say the first placeholder as this. Okay, like this. All right. So basically, these three, this, and this are identical. Okay, so all right. So I'm just showing you this. So these four are identical. I'll just take up the line that we defined earlier at the top. Okay, so you can see that these four, this, this, and this are identical. Not clear? Is the font good enough, or should I increase the font a bit? So what we are doing is we are passing the function as argument. That's the most important part, right? We are passing the function as argument, and this function is being called on every element of the list, right? Okay, is it clear? So what map does, it takes this function, runs it on every element, gathers the output, and gives you that result. Okay. A question from Binta is, could we change the list and use array, set, and tuple and map for the map functions? Yes, but the tuple, it wouldn't work. Okay. If we have a tuple here, let's say we have a tuple here, tuple is not iterable. Okay, if we have a tuple here, right? Let's say this is my tuple, and I try to call map on this. Okay, so capital T dot map, and I just say this. Okay, so it says that the value map is not a member of this class. Okay, this class is nothing but a tuple. All right. But it should work with the set as per my understanding. Okay, so you can see that it works with the set. So anything that is iterable, it can work with that. Great. All right, and remember that if this is a map, this is a map. Okay, let's say this was a map, right? And let me just show you this. M equals map of, all right, M equals map of say A equals 1 and B equals 2. So if we call something like this, it is right. Okay, it says that we cannot append 1 to this. Okay, we cannot append 1 to this. So why? Because this one is essentially a key. Okay, so if you take a look at this one, what happened was it essentially appended the xxx to the tuple. Okay, it appended xxx to the tuple. So we could actually say this, let's say whatever is the value, and say, give me only the first value, right? So give me only the first value, and you could take a look at the outcome. See that? So we basically extracted only the keys from the map. Okay, if you wanted to just extract the values from the map, we could use this kind of a way. Why? Because this X is what? A tuple of key and value, and for every element, and then we can use these, or we could just say K and V like this. Okay, and here we'll return K. All right. No, without brackets, it should work. It should generally work. Wrong value of parameters, expected one. I see. I see. No worries. So we can basically use it like a tuple, because when we are mapping, you get a tuple and you can convert that tuple um, into the first argument or second argument or whatever we are expecting. Am I making a mistake here? We just did, right? It worked fine. Oh, we did. We did not say this. Okay. All right. So I hope this is clear to you. No? A question from uh, okay. So a question from Grishma is set.map underscore plus one. What did it do? So here, what it did was it basically executed this piece of code for every record. And this underscore is a placeholder for the original value. So it'll become 2, it'll become 3, it'll become 4, it'll become 5. That's what is happening here. All right. So you can see we can actually do things like even this, that we can check if the value is true or false. All right. A question from Binta is that m.value.map, m.value.map, okay, underscore plus one. How about m.value.map underscore plus one? Okay, m.value, what is m.value? Oh, you mean like this? m.values? Ah, I see. So there also you can actually do map here. Okay, we could do that. Okay. All right. So we have increased, returned the value of values and given by 1. All right. So this looks really sleek because when we have to go through an array or a list, we don't have to write the for loop. We can generally utilize map. Now, what's the advantage of this approach, and what are the disadvantages? We'll talk about later. We'll compare the for loop against map. Before that, let's understand a similar function called flatMap. In case of map function, it can only return as many values as the input list has. Input iterable has those many values, it can return only that. While in case of flat map, it can return more values. Okay, so flat map takes a function as an argument, and this function which it is taking as argument must return a collection. And this returned collection could be an empty collection. So, and this return collection could have many values. So the flat map applies a function passed to it as argument on each value in the collection, just like a map. Okay, so flat map applies the function that is passed to the argument, passed to it as an argument, and then it takes that function and applies on every element, just like map. The difference is, in case of flat map, the number of returned values could be more or less than actual value. Okay, let's take a look. So I'm going to take another example here. Okay, I'm going to take a bit different example. Let's say, okay, let's take a look. Let's say we have a function, right? We have a list saying this is a cow, okay, and this is let's say this is a duck, right? So we have this list, and let's take a look at the list. How does it look? So good. It has 2 sentences. There are 2 elements in this list. Okay. So okay. So how many elements are there? There are 2 elements in this list, correct? So let's say we want to split each of this into words. So we define a function called to words, right? And we are taking as argument as string, right? And what is it that we are returning? We're returning a list of string. Okay. And how does it work? We are simply saying return s dot split. Okay. S dot split, and we could say split by space. Okay. What does it say? Oh, it returns an array. All right. We can make it far more simpler. We can make the same function far more simpler by just doing this. Okay. We could just define it like this. Okay. So we just defined our 2 words, which basically whatever you give it, it will basically convert that into an array of values, right? Array of values. You want to check the length of it, you can check the length of it. So there are 4 things it will return. All right, so we just wrote a very simple function. What it does is it returns you the words from a sentence, right? Everything okay so far? No? Good. I hope I have not put you guys to sleep. And right. So Alok, Bharti Raja, Bintao, David, Grishma, Hari, Hitendra, Jay, Mohammed, Prashant. I'm sure Prashant has gone to sleep because he is in Singapore. Okay, and it will be like 2.5 hours ahead. Okay, yeah, see, right. Oh, you are awake still. Good, good. All right, so let's move ahead, and I'm really happy that you're awake still. Great. So let's right. Uh, All right. So this is something really interesting that we're learning, because here this is where the boundary of distributed computing is starting, right? So here what we are doing is we are going over the instead of going over the list the way we did, like using while loop, do while loop, or for loop. Here we are writing a function and handing over to Scala that, hey, can you run it via the map, right? So we are not iterating. We are not iterating. Instead, we are letting Scala's map function do the job. And this is a total mind shift from the usual programming. Here, we are defining a simple function. What it does is it breaks a sentence into word. But if there are a list of sentences, we are not going to iterate over the list of sentences. Instead, we are going to use something called a flat map. So we're going to say list dot flat map and then give it this words. Okay. Now you can see that it has returned a single array. It has returned a single array containing the words from all the sentences. The words from all the sentences. Okay. So if we had the lines of text from a file, we could actually just call this list.flatmap, and two words, it will basically convert the entire file into the list of words. Okay. Is it making sense? Now, the difference between flat map and flat map is, okay, so in case of a map, if the input is having, okay, so when we say list.map and we are passing a function, and this is a new list, okay, this is a new list, okay. Question to all of you is, will new list and list have same size? Yes, no? Okay. Now, in case we are using flat map here, will new list have the same size? Answer was yes. And will new list and the list have same size? That's right. That's right. So basically, flat map is different. Flat map is different exactly in that sense that flat map, the function that you are defining, it must return array or list or anything that is iterable. Okay, so it must return something which is list of things or array of things or anything that is iterable, so that when flatmap runs, it'll gather the output of all the two words and combine them and create a new list. Now the further question is, what will happen if instead of calling flat map we called map, right? Let's say this is new list. Okay, this is a new list. Okay, so new list, you can see the length of new list. It has two. The new list is of length 2, and each element of this new list, you see there are two arrays in it. Okay, so basically our two words was called on every element of the list. This list has two sentences. Now two words broke down that sentence into an array, and that's what is returned as is. While in case of flatmap, both these arrays got combined to form the final list. You can see the difference. Okay, so that's what is the flat map. Now, similar to that one, so these are higher order functions: map, flat map, and filter, and there are quite a few of these. And these are very useful because it basically avoids the writing of for loop. Okay. A question from Mohammed is the length of flatmap output will be double? No, flatmap output could be anything. Flatmap output could be anything. That's the important part. So flatmap output could be smaller or bigger. Let's say here basically our function was not returning anything. It was basically this two words function we defined here. It is basically returning. It is basically returning empty array. Okay, basically returning an empty array, and when we call this here, it returns empty. Okay, this is the important part. It is the map function. Make sure that it would give you exactly same number of elements as the input, while the flat map combines the result of all the two words and then gives you back. Therefore it could be less, it could be more. Okay, so flat map basically gathers the list from all the executions of this function. Okay, it executes this function against every element of this list, and then gathers the result. And once it gathers the result, it combines them to form a single list. Okay, so flat map executes your function two words here. Okay, and breaks it down. It takes your two words function, calls it on every element of the list, and then it combines all the values and gives you back. Okay, okay. A question from Grishma is that what if we call this empty one? Let's say we have this nice function which does nothing. Okay, let me just define this. This is a good question. So I'm defining a function called two words. It's returning nothing. Let's say it's returning an empty array. Okay, it's returning an empty array. Okay, so whatever you give it to this one, it'll basically do nothing and will return you empty. So you can see whatever you call this function with, it will return nothing. Now this is our list, right? It contains two sentences. Now if we call this list with map and these two words, which is returning nothing, what will happen is, okay, what will happen is, sorry, what will happen is, it'll basically return this. Do you see the difference? It is returning two objects of array which is empty. While if you are calling this with flatmap, okay, the length of outcome is 0. All right. Now let me write something sensible here again and try to show you what it means. Okay, so let's say this one is returning whatever we're saying s dot split. Okay, now what does this one does? It basically splits it. So let's just test it. We just tested it. Then this is the list that we are having. It has two strings. This is string and this is string. And now if we call this function using a map, what will happen? This will call this on this sentence as well as this sentence. Whatever is the result, it will create a new list and keep that in that new list. You can see this array and the another array. Happy? So basically the map function does that. Now flatmap, what it does is it basically takes a function which returns the array or list. Then here it's going to execute this against every element, this as well as this. And when this function is called on this value, this is a cow, it's going to return this is a cow, right? This basically is going to return an array. Then this function, when it's called on this string, is going to convert that into an array. And then it is basically then concatenating these two arrays. So flatMap concatenates the two arrays and creates a final list, while map does not. All right, is this difference clear between the map and flatMap? So when you want to convert one record into many, you use flatMap. If you want to translate just one record into some other record, then you use map. Okay. Do you guys want more example? All right. If it's not clear, I can give you more example. Alok's question is map and flatMap will always create a new list. That's right, or modify the same list. No, they create a new list. And I think map will modify the same list internally, but flatMap, no, actually they basically, if that was the case, then our list would have changed by now. Okay. All right. So flat map here is basically about converting one record into many. Like the opposite of flat is generally group by in case of SQL, which groups multiple record into one. And here we are converting one. Here we are converting a record, one record into many records. Okay. Now should we? Okay. Let me give you another example. Imagine. Okay. Um, okay. So all right. Okay, so let's say that in a class, let's say in the class, we have this list, or let's say we have a map. Okay, it has okay, so let's say we have a class which contain these sections, right? These section. Okay, each section has list of students. Okay, it has list of student like student 1. Okay, this is section 1. Okay, section 1 contains student 1, student 2, or okay, like this. Let me just say this. All right, let's say we have this map which contains multiple sections. Okay, and here let's say we have second section as well. This is second section. Okay, this is section number 2. It has student 4, 5, and 6. Okay, so what happened here? We are saying list equals map. Okay, we have to say where. Okay, so this is the list of students that we see. There are two sections, section 1 and section 2. Now what we want is we want a singular list of the students. Okay, let's say we want the singular list of the students. So what we do, let's say we say list.map. Okay, and we return for every element in this, what we are going to return, the value of it. Okay, so it returned us the arrays, correct? It returned us the arrays, but we want a single list. In that case, what we're going to do, we're going to say flat underscore map. Okay, so you can see that we got the list of students very simply. All right. All right, so this was a quick example of using the flatMap. Now there are higher order functions such as filter. Filter applies a function to each value in the collection. Filter applies a function to each value in the collection and returns a new collection with only those values that satisfy the condition specified in the function. Now, what does it mean? Okay, imagine that we have a list of languages, right? We have a list of languages, right? And what we want to do is we want to only keep the languages which contain capital S, okay, which contain the capital S. So we can say filter, and here we have defined this function. What this function does is this function returns either true or false. So this function, this anonymous function or lambda function that we are passing here to the filter, what it must return, this function must return true or false. So this function that you see here will be called on Scala. Then what will happen? Then it's okay. So when this function is called on Scala, then it will check whether it contains S or not, and so on, right? I could do a cool thing here. We could write a separate function called contains S. Okay, so the argument to this is a string, and it returns another string. And here we are saying if let's call it lang, this argument. Okay, lang dot contains S. Okay, now here we are printing something, println, and saying applying on $lang, right? Just the way we did yesterday. We are saying applying condition on $lang, right? Just we are printing the debug message. Okay, now here we are also keeping the return value equals to this, and saying println and return value is equal to the return, right? Then we are returning the return value. So this contains method we are okay. This contains method. It should be Boolean. Okay. So contains method is simple function, right? Whatever whatever you pass to it, it basically prints some messages and returns true or false, right? It returns true or false, and it also prints this message. Okay, sounds good. Now let's check what is there in the list. List is this, and on list we are saying filter and applying this function called contain S. So you can see this contain S is being applied on Scala, it returned true. Then it's being applied on R, it returned false. Then it's being applied on Python, then it returns false, and return false in case of Go, and return true in case of SQL. So you can see that it has basically retained only the element when this function returned true. Okay. Does it make sense to you, the filter? All right. So this filter method is just like where clause in the SQL. So on the same lines, you can think of the map function like select statement in SQL. So yes, that's the right analogy. Okay. Now, each of the previous higher order functions, whether map, flatMap, or filter, they returned a new collection, new list, but after applying the transformations, right? Sometimes we do not want any return value. For example, let's say given a list, we just want to save it to disk. We don't want it to be returned to anywhere. So for those kind of cases, we can use for each. For each is just like map, except that it does not return any value. Instead, it just executes the function and returns nothing. So for each applies a function to each value of collection without returning a new collection. For each applies a function to each value of collection without returning a new collection. Okay, so this is an important part with respect to for each. So with for each, we can actually call any method, right? Any method that returns or doesn't return anything. So let's say, for example, here, if we call our contains method as for each, okay, it will be called, but nothing will be returned. Okay, nothing will be returned. So now the next important function, very important function is reduce. Okay, imagine that you have a list of some values like 3, 7, 13 or 16. So, and we want to add them. One way to add them is by way of looping, but what reduce does is reduce takes a function which operate only of on two values. Just like this plus function, it's adding only two values at a time. So that addition function is going to be called multiple times again and again. All right, again and again, just like this. So first addition was called on 3 and 7, we got 10. Then addition was called on 10 and 13, we got 23. And then addition was called on 23 and 16, we got 39. So this reduce function basically calls your function again and again until we get a singular value. Okay, so let's take a look. So in the previous example, basically the addition of two variables was called again and again until all of the values got reduced into a single value. Please note that in case of reduce, input collection should contain elements of same data type. All right, let's take a look. Let's say we have an element, right? Let's say we have a list, right? List of elements 1, 2, 3, 4, 5, 6, correct? Now we want to find out. All right, do you want me to commit now or maybe at the later? All right, let me see if I could just commit it. All right, so we could say git commit, and we could say minus this, and I'm saying the class work, and then I'm saying ampersand git push. So both the things would happen in a single shot. Okay, now we have this list which contains numbers from 1 to 6, and let's say we want to find out the summation of this, right? Summation, the total of this list. So what we do, list dot reduce, and here we're getting two arguments and we're returning x plus y. Okay, x plus y, it should work just like this, right? So you can see that basically this simple function, what does this do? This simple function is equivalent of saying def my add x comma y, right? X comma y, and these both are integers. These both are integers, and we're going to return an integer, and we're just saying x plus y. Okay, and we're calling that function mySum. Okay, so we are saying list.reduce all right, so let me just take it out, make it two cells. All right, Great. So you can see that the list.reduce basically reduces the entire list into a single element, right? Now, let's say we want to create a function which finds the maximum value. So it's pretty simple. I'll say my greater, right? I'm just writing a function called greater, okay? And we just return the greater value, okay? So I'm saying x is integer, y is integer, and we are going to return an integer. And here is my value, right? So we are saying if x is greater than y, x is greater than y, return x, otherwise return y. So we just wrote a function to find the greater of the two. Okay, we can just check if it's working or not. So here it is working fine, right? But no, but it's only finding the greater of the two. Now, if we call the same method on the list, we say list.reduce and call the greater, right? We call the greater here. You can see it has been, this greater method was called again and again on this list. First it was called on 1 and 2, we got 2. Then it was called on 2 and 3, we got 3. Then it was called 3 and 4, then and so on, right? So basically, if let's say the greater was in the beginning, right? Greater was in the beginning, then also it'll basically give you the results. So these will keep on comparing and it'll give you this. Okay. Similarly, if we just put the lesser sign here, then it'll find the minimum. Okay, it'll find the minimum, and the reduce is therefore quite a useful function. It reduces all the elements into a single value, all the elements into a single value by the way of provided operator or provided function. All right. It is always a single value. That's right. Okay, so the same thing what you see here could be also written in further more shorter form by saying plus and plus. Okay, so you can see three variants: first variant, second variant, third variant. Okay, here we have written second function called greater, and we've called greater on the reduce. All right. All right, so now that was the interaction with the higher order functions. So you can actually experiment a little bit more on the higher order functions. We can interact with Java. We can interact with Java just like normal way. We could use Java and get started with various objects and so on. And all we need to do is just import the Java classes, right? Like let's say there is a Java class called import java dot utils dot date, not utils, the util. Okay, so the date has been imported here, and we can just use the date as if it's the local object. All right, so you can see that this is basically the Java object being created. So anything that we have defined in Java, we could just use this, import and import that, right? So we could import like system dot out dot println, right? And then we can use the println here. Okay, now this will not work. Oh, it will work, right? So in the similar way, if I just say import system.out and can use that out.println. All right, so you can see that we are able to interact with the standard Java objects happily. Okay, And I'm just wondering if I could use import java.text dot string builder or string buffer java.utils, right? Or text string buffer or something. Right? So we can actually say if we don't like these lists of, if you are coming from Java background, you could simply say, I don't like this list, so we'll just use the other kind of list, right? And does it take this way? We have to put new here explicitly. And here we could just say this, and then x dot, what was that? X dot add. Okay. Oh, we have not defined the data type. So I think we need to define the data type. So you can see that we are able to add we are able to interact with the Java libraries very happily. Okay, so just like any other thing. All right. So yes, and in the same way, you could actually use any of the libraries from Java. This is the important part. If you are A question from Mohammed is, can we write Python code too? Okay, that's just too much to ask, but no. The reason is that under the hood, Scala gets compiled into Java, and therefore anything in Java is available to Scala. All right. Great set of questions. Now, the next question is that when we are building larger, okay, so did we cover? Yeah, we have some classes also. So the next point is that when we are working on larger projects, then we generally use SBT, the Scala build tool. Scala build tool basically helps us compiling hundreds of source files, and basically it makes the life easier by making by by using the SBT. Ideally, what happens is, let's say you're working on a project, right? Now, if you're working on a project, what you will do, you will create various Scala source files. You'll create the functions, you'll create the classes and so on, and you will save them to the local disk, right? Now, it's not physically possible to actually do Scala C for everything, right? Therefore, you always use a build tool like SBT. SBT makes the whole process extremely simple. We need a build tool to manage the compilation in most of the production environment. If you are in the production environment where you're not using a build tool, you must consider using one, because that makes the life easier, really easier. Nobody compiles things in the production using text editors or single commands. If you have a larger projects with multiple files, it makes sense to use SBT. SBT is a build tool for Scala as well as Java projects. It's similar to Maven and or Make in case of Java. In case of C++, we use Make, and in case of Java, we used to use Maven or Ant, and there are quite a few other tools as well for building. Right. So let's take a look at this code. let's take a look at this code. Here is a sample. So the way it happens is, in case you are building a larger project, right now whatever we did in the notebook. But in the production environments, what you do is you generally have a larger project like this. So at the top level, you define a file called build.sbt, in which you define the name of the project, version of the project, and here we are basically defining the version of the project, and we are defining the version of the Scala that is required, minimum version of the Scala that is required. So these are the minimum 3 things that you need to define in case of the build file. So this is build.sbt, is really simple build file. Okay, and the SBT works on conventions. So in this folder, you must create src, main, and then Scala. In case of you have testing, then you will have src. So you will have test, main, Scala, like that. If you have more languages, you will have src, right, main, and Java. So like that. So at the top you have either src or test. Inside both of that, you will have main, and then inside that you'll have per language. Okay. All right. I'll show you a bigger picture where there is so here, let's take a look at. So SBT works on conventions. So you have to ensure that you follow that convention. Here there is a project of Spark, and here you can see there is a folder called src. Inside src there is main and test. So I was wrong. Basically inside src you have main and test. Inside main you have the language name, and then you have the package name. Okay, so this is the general structure of your code. Okay, so this is the general structure of your code. Let me just explain it here. Okay, all right. So inside this you have to have your build.sbt. This is where you have your build.sbt at the. Okay, now inside src you have these 2 folder, either main or test. Test is for test cases. This is for test cases. This is for test cases. Okay. It's important part because that's what actually confuses us mostly. So that in the build.sbt there was no file available. Okay. And test cases, and this is the main code. Okay, this is the main code here. All right. From here, this is the language of your choice. Here you see, this is the language of your choice. This is the language. So this is the general structure of the, it could be language, could be Java or other languages. Okay, it's good thing because it helps us organize our content, our code. So from here till here, okay, this looks awkward. So from here till here is the package. Okay, is the package. So generally we write the package name as the opposite of the domain names. Okay, com.cloudxlab, like com.nobigdata or something like that. So like that. So basically that makes sure that your classes do not collide with other things in the project. Right? If it was Java classes, Java would have written like Java/Java/Java here, and then /util/date. Okay. Similarly for Scala dot say mutable dot collections. So it would be here there would be a folder called Scala, then mutable, Scala collections mutable. Okay. This is the package. This automatically infers the package, and this is your code. This is your code. All right. So this is an example of okay. This is an example of the typical project, and okay. So where did my okay? Here's my project. So all right. Now going back to where we were. Okay. So we were here. All right. So in the Scala project, in the Scala folder, we don't have test cases, but we have the main code. So this is the src main and Scala. There is no package name we have defined. Okay. In the hello world class, we have this definition. You see, here we are saying object hello world and main method is println, and that's it. Okay. So main method is println. So let's try to execute this. Let's try to run it and see how it works. Okay. The way we run it is go to this top level folder, because here where you have the SBT, the build.sbt, we will change the directory to this location. Okay. And then we will do SBT compile. Okay. So all you have to do is git clone, say this repository. Okay. You can git clone this repository. Okay. And so this file convention is something that you have to stick to. Okay. This is a standard file convention. It's going on since like 2000s. And that's how basically we do that. So that's how it has been going around. So if you have not, you have already cloned, use this mechanism to update the new version. Okay, so I'm going back to my console. So I've already pulled the latest version, so I could just pull it again. All right, so what I did was I went to big data folder, did git pull because I had already cloned. Okay, so this cloning, if you have not done it already, what we are doing here, we are getting the code from our GitHub repository. This is a public repository accessible to all, and in this we are going to this folder and going to go to which folder? We're going to go to Scala folder, and in there is SBT folder. Now here you see build.sbt. There are these extra folders. We can just remove those, and yes. So right now we have only this, and to take a look at the structure, we can just say find dot, right? It displays us everything in the current folder. Okay, in case you have just too many files, it will give you a huge result, right? So you can see all the files and folders in this current directory. Now we're going to say SBT and say compile, right? We're going to say SBT and compile. So we went to this folder. Okay, we went to this folder and we went to we went to this basically this right. The here this is where the sbt dot build.sbt file is located. So Scala files must be located in this. Okay, then we can say sbt compile, sbt run. So we can also say sbt run. It won't compile again, it will just run. Okay, it just discovered the main method by itself by matching the entry points. Okay, okay, it says that the valid command not okay. All right, so we were able to successfully run the run the this particular method inside hello world. So this was executed. All right, so all we did was SBT run, and that's it. Is everybody able to execute it? So do the git clone, then go to this directory, and then you say SBT run. All right. Okay, Rajan, you could share your screen quickly. I could help you out so that others can also solve. Okay, looks like the memory issues. You could try again and it should work. Okay. All right. Okay. So let me just check what's wrong with F. All right. So these are all our classes, right? Okay. Okay. All right. So looks like the Jupyter has eaten up all the memory. Who is stack KNOHA? Is that somebody from the class? Is that Karan KEDU from our class? Just give me a second. I'm just trying to like.
Sandeep, should I switch to some other box?
No, yeah, you can try with the G. Okay, you could try with the G. Okay, can you try again? Just once more on the same machine.
Yeah, still getting the same.
Still getting the same error. Okay, I think just shift to G. Okay, just shift to G. All right, I think it'll be difficult right now to, you know.
Yeah, this looks better.
Okay. Yeah. So it's comparing now. I think that was, yeah. All right. Great. Great. So I think for others, it did work. So you just try the SBT run. It should work. Okay. Great. So everybody was able to execute. All right. Yeah. Okay. So is there anybody else who is facing the issue? So the way memory issues were solved, that is shifted to, I think, G, right, instead of F, and that for now that is a quick fix because it's not right thing to kill somebody's process right away. All right, so great. Any other questions? Should we go ahead? So if you are if it is running fine for you, then it should generally display hello world here when you run SBT command. So when you say SBT run, oh, for me also the same problem is happening. Okay. Okay, if I just stop my kernel for a minute, then does it help? I think the Jupyter is consuming a lot of memory. Maybe if we just refresh the reload our Jupyters, it'll actually give the memory more back to others. Okay, so all right. So I just stopped my Jupyter on E and it worked. All right. Right, right. Actually, this Jupyter is consuming memory. So you just refresh reload your window, then it should be fine. Okay. Reload the window and it should be fine. Great. Now that's about the executing something using the SBT. All right. Should we move ahead? So the next topic in the Scala is the case classes. So Scala provides you the normal classes. What are the classes? Classes are nothing but the custom data type. When you want to define your own data type, then we basically define the classes. Okay, so we can create our own classes using Scala. Have we talked about classes earlier? I'm recollecting that we have defined the classes earlier. Yeah, we have done the classes, right? Okay, great. So classes are just regular classes. Like what are classes? Typical, the normal one. But those who are aware of defining classes, they would agree that defining class requires a lot of hard work. You need to define a class, you need to define hash code method, you need to define toString, and so on. So for that, Scala came up with a shortcut called case classes. With case classes, you can instantaneously define the case class. All right, so that's pretty much for today, and we will continue from case classes. And in the next Saturday, what we are going to do, we are going to work on Spark. And whatever we did today, you must try all of these by yourself. I'm committing the code, and that should be good. All right, thank you, David, and thank you, Alok. All right, so we'll put a stop here because I think that's pretty much. So we'll continue from the case classes, and we just have, it was the last topic for today. And we will, next session, we'll just cover the case classes, and then we will continue with the Spark. All right, so thank you, everyone. Have a good day. Bye-bye. So
Hi, Sandeep.
somebody wanted to stay back? Yeah.
Yeah.
All right. So those who have questions, they can stay back. All right. We are not going to discuss any of the topics. We basically are going to answer your questions. All right. So those who want to be, yes, go ahead, Mohammed.
Hi, Sandeep.
Yeah.
So my case is like I'm graduating this semester
Okay.
from with like a master's in computer science.
Okay.
So my overall idea of taking this course was to get some hands-on experience,
Right.
which can be applied in the industry as well. So
Okay.
I just wanted to know like what additional steps should I take parallelly with what I'm learning right now. So once I'm done with the course, I'm like, okay, and I'm industry ready.
Okay. Okay.
So that's my
So
question.
right. So I would suggest that here, right? See, in industry, the difference between the normal education and the industry is that when you go to the industry, people expect you to know, like the build tools, the Git, the usual way of coding. So coding is, of course, we expect from anybody, but when somebody comes to the industry, we want them to at least know about what is the, let me just put it down. I think that will be a better way. Okay, so, all right. So let's say we would like to know somebody about Git, right? Not GitHub, Git, right? The second part, we would want people to, we expect people to know a bit about SQL, okay? And of course, we expect people to know coding. They should be able to code and build things. The classes and object also we kind of expect, okay? We assume that people know classes and objects and the one that we discussed earlier. Now, other than this, the foundational things, if you are going for a web company, right, then the standard HTML, CSS, we assume that people know how does the website work, right?
Yes.
So that we expect website, okay. And REST is, I think REST. Things like the things like continuous integration is something that you will learn when you come to the industry, and those are the build process. And here one more thing is the build tools, right? Build tools like SBT, okay. Also, so what I would suggest is the easiest way to get ready is probably, this is the one that I created exactly with that mindset, that you should get ready with the industry. If you go to my courses,
Okay.
if you go to my courses and go to say this particular course, okay. So here, this one walks through kind of very foundational stuff, and you'll be completely comfortable with this, okay. So it talks about all kinds of applications and so on. And then, so you try this one. I think this will be quite useful for you, other than these basic stuff that we talked about. So rest it is up to the industry. Also, when we talk about coding, people do ask you the data structure sometimes, okay. So if you are going for a job interview, and so go through basics of data structures, right? Data structures, say, for example, there are these websites like Geek for Geek and others. So take
Yes.
a look at those, though that will be also helpful for you. All right?
Actually, my case is that I am currently in the US right now.
Mm-hmm.
So, and you stayed in the US, so you exactly know like how it works over here. Right now, as per the market, they expect a lot in order to give you a position. So, in
That's
order
right.
to get like a data engineer position in the big data ecosystem,
Right.
what would
Right.
be like the minimum amount of tools that you should know, like hands-on?
Hands-on, I would say that Scala with Spark will actually make you sail through.
Scala with Spark,
Yes.
and how about like HDFS and Kafka as well at the same time?
Those things are not that difficult to pick up. Those basically, when it comes to HDFS, is basically the architecture of HDFS, and
Mhm.
that anyway we have included here. Okay,
Okay.
so we have already included here. So those things you can really pick up very quickly if you take a look at, say, my course here. Okay, so here in your course you will see the Linux basics. Yeah, I kind of missed that point. This is a very important one. Do not miss this part. Okay,
Linux.
yes, do not miss this part, because a lot of colleges, universities are making the mistake that they are kind of thinking that Linux is kind of optional. But when you come to server-side programming, trust me, everybody works on Linux. Oh, all
Yes.
right. And second is that even the Windows is shifting to the same shell. They are basically have ported the shell, the one that we use on CloudxLab. Similar to that,
Mhm.
they have basically pushed the shell in the newer version of Windows, so that you could do this. So basically, finish this part. Finish this part. If you want Java Essentials, go through Java Essentials, and sometimes people do ask for the basics of this. Second, go through these topics. These topics are useful. These are HDFS, Yarn, and Zookeeper. And if you go back to Scala one, the one that we have on Scala, okay. Okay, so we have, let's say, the Scala here, not Scala, the Scala with Spark. Where is that? It should be somewhere. Big data with Spark. I think this is the one, right? So big data with Spark, if you take a look at that one. So you finish the Linux basics. You finish, if you want, this is kind of optional because you are anyway going with Scala. And this is Zookeeper, HDFS, Yarn. These are very basic topics you can quickly finish. And this one you are anyway studying. And
Right.
also finish this part. I mean, that this will basically sail you through. Other than this, the one part that you might have to go through, this is covered in the course. This anyway we are using already. This is something that you might have to work a bit. This you
Okay.
might have to work a bit. This is kind of covered, and this is something that you might want to work on.
Web
Okay.
development.
Yeah, well, I just get an idea that what's the server, how does it work, and things like that. These parts we have already covered. So these are the extra, maybe a couple of things than what we are having here. All right.
Yeah, I understand. So by the end of this course, I'll have at least some hands-on on what we are learning right now,
Yes.
right? Because
Correct.
these are
Correct.
like little programs which are meant to be integrated into the big programs, into the big
Right. Right.
applications.
Right.
So
So SBT, the one that we talked today, is kind of gives you a bigger picture that if you have a larger project, like multiple people working on it, so they will have a single repository, some people working on one file, some on another, and we'll compile using the SBT, all of them together.
correct.
Okay.
Yeah, I understand. And I actually have a suggestion. So
Mm-hmm.
actually, as we have sessions on Saturdays and Sundays, right?
Right.
So if you could send us an email regarding what are the topics that will be covered in the Saturday, Sunday, and if we
Okay.
skim the topics, it would be better, right? So you'll have more doubts to cover. Some
Okay.
basic questions that we ask in the chat box, those can be avoided. So I think we can cover more ground if we know in advance what topics are going to
Okay.
be.
Okay.
That's
All
what
right.
I feel.
All right. All right. So actually, what I expect people to know that this you see here, big data with Spark, we are going exactly in this flow. Okay. This one is foundational, so we are assuming that you have gone through this. We're
Okay.
going to go through this flow.
So
All right.
9, 10, 11. Okay. That's
All
the
right.
order that you follow.
That's the order we are following.
Okay. I
Okay.
didn't know about. Thank you for letting me know.
All right. So all of us just keep that in mind. So this is the flow that we are going with, and we are going to go with this flow. So make sure that you are into this direction and utilize the class for asking and questions and clearing it out.
Right. That's correct.
Okay. All right. Let me also commit the code. Okay. All right. Yeah. Any other questions?
No, thank you so much for the classes. The classes are really nice.
All right. Thank you.
I just want to get a lot of hands-on experience because I already kind of know the theoretical part, but I just
Okay.
wanted to get the hands-on experience.
Wonderful, wonderful. I think then this would be a good start for you, and make sure that whatever we are doing in the class, you do it with us, or do it in the class or after the class, and
Yeah,
that's a
sure.
message for all. And it's going to be because things look really easy when I'm typing it or copy pasting it, but when you want to do something different, even a little bit, you will find that it's actually fairly different. Okay, so then you
Right.
have to research at your own, you have to search for things, you have to debug them and so on. All right, so great. All right, so thank you everyone. Any other? Yeah, Hari, you have a question?
Yes, Sandeep, I'm getting the same error, memory error. How did we get through?
Okay, so which machine are you on?
1 second.
So others, if you're done with the Scala 1 notebook, you can just close it and go to your running Jupyter and shut it down. Okay, I'm just shutting down the running Jupyter.
It's
So,
179. I think it's in E.
okay, does it say jupyter.e or jupyter.f in the URL?
No, I was just trying to get the Git and run the SBT run. I didn't actually go to open the Jupyter part. So
Okay. Show me the console. I'll take a look. Just share the screen.
one
Okay.
sec.
Mohammed, is it okay to mute you? Okay, I've done. All right. So yes, Alvin, I have committed the code, and the link is basically the usual GitHub repository. So you say github.bigdata, right? github.com/cloudxlab/bigdata. Inside that you will find the Scala folder. You'll find the Scala folder, and there you will be able to see 7 April, right? It is continuing from the last uh, session. Okay, now I'm not able to see your screen. You could share your screen, please, Hari. I'm waiting for that. I can just take a look and then.
Yeah. Are you able to see it now?
Not yet. Yeah.
No.
So, but you have here. Okay, here it is e.cloudxlab. So you are on E. Can you try again, please? I have just shut down a few of the processes.
Oh, okay. I think it's getting in now.
Okay, can you show? Can you clear the screen? Press Control L. Control L.
1 second.
Can it's not visible to me.
1 second.
Okay.
Now?
No, it tells you that. Yeah. It is now working. Good. It's now actually downloading all the libraries that are required in Java in Scala, and then it will run it. For the first time,
Okay.
it will run First time when you run SBT, it's going to download the jars and then do that.
Okay. Okay. No, earlier it wasn't even coming here. Yeah. Thank you.
Okay, great, wonderful, wonderful. All right, so great, great. Is anybody stuck? And yeah, that's pretty much for today. We will whatever we have discussed today. I would request all of you to go through that and try by yourself. We have actually discussed a lot of things today in Scala, and try all of those by yourself, and either on the console or on the Jupyter. You should try all of those aspects, and I look forward to see you in the next session. So thank you, everyone. Have a great day and a great week ahead. All right. Thank you, Alvin. Thank you, Bharti Raja. Thank you, Bintao. Thank you, Grishma. Thank you, Hari, Hitendra, Rajan, Raju, Robin, Sachin, Shravanti, Saris, and Subbu. Great. Bye-bye. Have a good day.